Yeah, let's have a look now. So this is the major one, which is called thermodynamics. One of the questions from thermodynamics is fixed in the exam, which means within this chapter, one question will always be there. Now, few things from AS that we got to remind ourselves with is the relationship of work done with change in volume. That's what we're going to start with. So in AS, we learned that suppose there is a syringe like that, and the syringe is pulled like this inside by a plunger like that. So initially, if this had this much of a volume, let's call this green one as V1. So when it was pushed from this point to this point, we covered a distance of h. It has an area A, which is the same. And because of this, now we have decreased the volume, and the new volume is V2. So this has caused a change in volume because of a force acting here. So work done, we've learned, is force times the distance. And we also know that force is pressure times area. Or pressure is force over area, simple, right? So we're gonna replace this force right here. So work done will be pressure times area times distance. In this one, I'm going to write change in D because that has occurred here. And we must understand that change in volume, the change in volume, which is V2 minus V1, is because of the area multiplied by change in distance moved. So I can simply write work done as pressure times change in volume. This is the formula we learned in AS and we need in A2 as well. The only thing we need to remember is that this formula only works for constant pressure, nothing else. Okay. If you guys have any questions, please do let me know. Okay. Here. Now we're just gonna do a couple of things from IGs, O levels, just to get along with what we're doing, and then some few things from AS because we need to build up our knowledge before we get into the real thing. So one of the questions that in IGs we learned was what happens when a state is changing. We must remember that for any change in state, particles gain kinetic energy and they vibrate. That causes them to go beyond their bond lengths. So they keep on vibrating. When they go beyond their bond lengths, that's when they turn from, like, the forces, they can overcome those forces and they can turn into liquid or a gas or vice versa. Right? So with respect to chemistry, there are two kinds of change. One change is endothermic. Endothermic change means that when, let's suppose, solid is going into liquid, this is just an example. Endothermic means that heat is absorbed. So they're gaining heat in order to convert from a solid state into liquid. And then the other change is called exothermic, which is, for example, when it's going from liquid to solid, that's when heat is released, because now they're losing heat, and the forces, the electromagnetic forces between the particles, are gaining in value or magnitude, right? However, the most important part that I'm going to write in red is that during the change of state, there is no change in temperature. So they need kinetic energy for a while to basically come to the point where they start to change the state. But when it is changing, kinetic energy stays constant. So temperature is constant. It will never change. Like at 0 degrees, when the ice is melting, it will stay at 0 degrees. The temperature cannot change. It will start changing when it has completely melted. So you guys need to understand that. Okay. And in any change in state, because solid is melting, so the particles on the surface, they move. We need to understand that there are no fixed number of atoms on the surface. Like in liquid, they keep on moving. Gas, they keep on moving. Even solid, they start melting, they move. So you guys need to remember that they won't be fixed. Their places won't be fixed on the surface. Within that material, they might have fixed places when it's changing state, but on the surface, it doesn't happen like that, right? So you guys need to remember that. If you have any questions in this, please let me know. Okay. Then there are three different changes that we've studied before as well. One of them is melting. Number two is boiling. Number three is evaporation. This is all preliminary. Same thing you've studied before, so it's fine. In melting, basically, solid is heated. Particles start to vibrate vigorously. At their fixed positions. Always write everything in A2 with clarity, please. Do not miss any points. It's very important. They eventually gain enough kinetic energy to weaken the attractive forces between them. Okay. However, in solids, we need to remember there are still some electromagnetic forces left between them. So that's something you guys need to remember. In boiling, let me write it with different color. I don't want to mix them up. Liquids or liquid is heated and kinetic energy of all particles are very high. Because already they're like weakened forces. So at boiling, every particle has enough energy to escape. This is something very, very important. Only constitutes for boiling. So happens at a fixed temperature and throughout the liquid. Finally, remember that boiling happens when vapor pressure is greater than atmospheric pressure. Now, this is something very important to understand. Vapor pressure means that obviously this is the pot in which some liquid is boiling. So, when it is boiling, the particles of the liquid want to escape to the atmosphere. But there's already atmospheric pressure acting on it. The only way they can escape into atmosphere is when their own pressure is greater than the atmospheric pressure that is applied here. Otherwise, they cannot escape. So that's how. So, all right. Now comes evaporation, which is difference, a large difference. Let's see. First of all, it only occurs at the surface. So that's something you guys need to remember. Number two, fastest moving particles with largest kinetic energy escape the surface. So it means it does not happen throughout the liquid, it's just on the surface. So that's the biggest difference, right? Then more energetic molecules leaving surface causes average kinetic energy of system means the liquid itself, to decrease. This is the reason it causes it to have like a smaller, like it causes a cooling effect, right? So this induces a cooling effect right? And unlike boiling, which happens at a specific fixed temperature, evaporation can happen at any temperature. So that is the reason even in winters, our clothes which are supposed to dry, they take longer, but they do still dry out, right? Because dry up. Because for evaporation, you don't need a specific temperature. I hope you guys understand that, right? Let me know if you have a question here. Okay. So I guess this is enough information for today. Again, please take notes of everything because whatever I'm writing on the screen can be asked in the exam. So in A2, you might not even find these in the books, but in A2, in the syllabus, it's clearly written they can ask you anything from the previous years, from grade KG, kindergarten to this time, right? They can ask you. So please write it. It's very important. Yes, Samir. All right. So I will see you people in the next class then. Have a nice day. Bye.